When you sent over that research paper, Theories of Immune Recognition, is anybody right? Well, color me intrigued. It really got me thinking, like, we talk about the immune system all the time, but how much do we really get how it actually, works?
It is pretty amazing when you think about it, right? This
Right.
whole system working away behind the scenes.
Exactly. And this paper dives right into the thick of it, like how we even tell what's a threat and what isn't.
And the different theories researchers have come up with over the years to try to explain it all.
Which, from what I gathered, seems to be a point of, shall we say, lively debate in the scientific world.
To put it mildly, there are a lot of strong opinions about which theory is the right one.
So to make sure we're on the same page, let's start with the OG, right? The clonal selection theory.
Yes, CST, the bedrock of immunology. It's the idea that our bodies create this massive army of immune cells, and each one is trained on one specific bad guy.
Like each cell has one job, one target it's looking for.
Precisely. Each lymphocyte, that's a type of white blood cell, has a unique receptor. It's like, imagine a lock, right? And the invader, what we call the antigen, is like the key.
And when the right key meets the right lock, bam, the lymphocyte jumps into action.
Exactly. It clones itself like crazy to build up an army that's specifically designed to fight that one invader. Super efficient, or at least that's how it's supposed to work.
Okay, but then the paper throws us a curveball. What about things like, autoimmune diseases? That's our own system attacking itself.
Right. That's one of those things that makes you go, that's not quite right.
Because if it's such a precise system, how does it make those kinds of mistakes?
That's the million-dollar question. And it's one of the main reasons why scientists started to explore these other theories. I mean, the CST, it has a hard time explaining why our immune system doesn't just go after, well, everything. Like, think about all the bacteria we encounter every single day.
Or like, what about organ transplants? If it's just about self versus non-self, those shouldn't work at all, right?
Exactly. Yeah. There's obviously something more to it than just recognizing what's foreign.
So it's like our immune system has this whole other level of decision-making going on.
It's about understanding the context of the threat. Like, okay, this is foreign, but is it actually harmful? And that's where things get even more interesting. Because to deal with these, well, inconsistencies, scientists developed what we call the two-signal theories.
Two signals. So it's not enough to just have the right key anymore.
You could say that. It's more like, imagine you're trying to get into a super secret facility. You might have the key card, but you also need a special code or maybe a retinal scan.
Right. Double the security measure.
Exactly. So you've got these researchers like Brescher and Cohn, Lafferty and Cunningham, and they're saying, hey, maybe a lymphocyte needs a second signal, like a confirmation, before it goes all in.
So like a security guard in our top secret facility example, someone double checking to make sure it's really you.
Exactly. And often, the second signal comes from another immune cell, like a T helper cell. It's checking to see, is this a real threat, or are we good here?
Oh, I see. So the second signal is helping the immune system figure out not just if something is foreign, but if it's actually dangerous.
You got it. It adds a whole other level of nuance to how the immune system makes decisions.
This is already way more complex than I thought. But even with this two-factor authentication, it seems like there were still some head-scratchers, right?
Absolutely. The two-signal theory was a big deal, but it didn't quite explain everything.
So where do we go from there? What comes after the two-signal theory?
Well, the paper you sent, it dives into some even more, shall we say, outside-the-box theories.
Which I'm here for, by the way.
Of course. So one that really caught my eye is the stranger danger theory.
Okay, yeah, that one definitely piqued my interest.
And it gets to this fundamental shift in thinking about how the immune system really works.
Okay, I'm listening.
So instead of just looking for things that are foreign, the stranger danger theory says, maybe it's more about looking for things that are causing trouble.
So less about what it is, more about what it's doing.
Exactly. It's about contact.
Like a harmless little bacterium just passing through that wouldn't necessarily set off any alarms?
Right. Polly Matzinger, she's one of the big names behind this theory, and she uses this analogy of a cell screaming danger.
Wait, what?
Yeah, she says when a cell's infected or injured, it's like it sends out these danger signals, these SOS messages that alert the immune system that something's wrong.
Oh, that's kind of cool, actually.
Right. So it doesn't matter if the thing causing the problem is technically foreign or not. It's about whether it's disrupting the peace, you know?
Yeah, I get it. It's like the immune system's not just checking passports at the border. It's more like, are you causing a ruckus?
That's a great way to put it. And this was huge because it challenged this whole self versus non-self dogma that had been around for ages.
Which I imagine ruffled some feathers in the scientific community.
You could say that. But the paper didn't stop there.
Oh, there's more.
Oh yeah, we're just getting started. Because some scientists, they felt like even with all these new ideas, we were still missing something.
Intriguing. Tell me more.
So we've got this functional recognition theory. And the idea here is that our immune system, it might be even smarter than we thought.
Okay, now you've got my attention.
Imagine this, right? You walk into a bakery.
I do love a good bakery.
Who doesn't? So you walk in and you can smell that fresh bread. Yeah. Even if you can't see it, you just know it's bread.
The smell of warm bread, it's intoxicating.
The best. But the point is, you're recognizing it based on its effect, its aroma, not necessarily the specific ingredients.
Okay, so our immune system might work kind of like that.
Exactly. It's not just about the individual molecules, but the overall patterns of activity, the behavior.
So it's like the immune system is a detective, right? Looking for clues, putting the pieces together.
Exactly. It's about seeing the bigger picture, the strategy, not just the individual players.
This is getting more and more fascinating. What else did this paper dig up?
All right, so buckle up because this one is a doozy. We've got the criterion of continuity theory. And this one says that our immune system is, well, a creature of habit.
A creature of habit. What does that even mean in this context?
It means that what's familiar is safe. But any big changes, any sudden disruptions to the routine, that's what raises red flags.
So if the immune system is used to seeing a few of something and then suddenly there are a ton, that's when it's like, hold on a minute.
Exactly. It's not necessarily about the thing itself, but the sudden change, the deviation from the norm.
That's so interesting. Okay, so we've got all these theories, but there was one in the paper that was labeled mind-blowing, and it definitely caught my eye. The idiotypic network theory. What's so special about this one?
The idiotypic network theory, INT for short, proposes something truly revolutionary. It suggests that the immune system isn't just a bunch of individual cells doing their own thing. It's actually a vast, interconnected network.
A network? Like, are we talking like a brain here?
You got it. It's constantly communicating, learning, adapting, just like a brain processing information.
Okay, now that is mind-blowing. How does that even work?
Remember those antibodies acting like locks and keys?
Yeah, we talked about that earlier.
Well, the INT says that those antibodies, they're not just fighting invaders, they're also sending out signals to other parts of the immune system.
Wait, so they're multitasking?
Exactly. They're like little messengers, sharing intel, coordinating a response.
That is wild. So we've got this whole other level of communication going on within our bodies.
Precisely. And get this, the INT suggests that the immune system has memory. It can remember past encounters and use that information to mount faster and more effective responses in the future, just like our brains.
That makes a lot of sense when you think about how immunity works, how we can become immune to things after being exposed.
Exactly. It's like this incredibly intricate dance with
Yeah.
all these different players communicating and adapting.
This is way more complex than just that initial lock and key idea we started with.
You said it. The INT really changed the game when it comes to understanding immune recognition. It shifted us away from this linear one-cell, one-target model to a much more dynamic and interconnected view of the immune system.
That's amazing. It's like realizing that a single ant is interesting, but it's the colony as a whole that's truly remarkable. So if we're thinking about the immune system as this like bustling network, this whole society of cells, I mean, it makes you think about things like vaccines and allergies totally differently, right?
It really does. Suddenly, it's not just about training up an army. It's about understanding the language of this network.
Because like with allergies, that's the immune system kind of going rogue, right?
In a way, yeah. It's overreacting to something that's not actually a threat.
So how does this network view change how we approach those kinds of issues?
Well, let's take vaccines, for example. If we're just thinking about the immune system as an army, then a vaccine is like showing our soldiers a wanted poster of the enemy, right? But if it's a network, it's more like we're giving a presentation, explaining the threat in detail.
Oh, I like that analogy. Instead of just, this is the bad guy, it's, here's how to spot them, here's why they're dangerous, and here's what to do about it.
Exactly. And that could lead to even more targeted vaccines in the future, ones that don't just trigger a response, but actually help the network learn and adapt in beneficial ways.
So instead of just teaching the immune system to attack, we could potentially teach it to tolerate. Like, hey, chill out, this thing is cool.
Exactly. And that's huge for things like allergies and autoimmune disorders, because if we can understand the signals that lead to that overreaction, We might be able to rewire them.
Wow, that's incredible. It's like we're not just fighting the immune system when it malfunctions, we're trying to understand its language and retrain it.
Precisely. And that brings us back to your original question about which theory is right, because maybe it's not about picking a winner.
So it's less about one theory being right and more about each one giving us a different piece of the puzzle.
Exactly. Each one has contributed to our understanding. And it's by combining these different perspectives that we get this more complete picture of how amazing and complex this system really is.
That's so cool. It's like we're piecing together this giant jigsaw puzzle, and every new discovery gives us another piece of the image.
And just like with a puzzle, there are still pieces missing. But the more we learn, the closer we get to understanding the full picture.
And that knowledge, it could lead to incredible breakthroughs, not just in how we treat diseases, but how we prevent them in the first place.
Absolutely. And who knows what other mind-blowing discoveries are waiting for us as we keep exploring this incredible world of the immune system.
That's the beauty of science, right? Always something new to discover. But as we wrap up this deep dive, here's something I was thinking about. We've been talking about the immune system as this vast network, right? But everyone's network is a little bit different, shaped by our genes, our environment, all of it.
Right, like a fingerprint, everyone's immune system is unique.
Yeah. So, if our immune systems are that personalized, what does that mean for the future of medicine? Could we one day tailor treatments not just to a person's symptoms, but to their unique immune profile?
Wow, that's a really interesting question.
It really makes you think. And on that note, we'll wrap up this episode of The Deep Dive. Thank you so much for joining us as we explored the fascinating world of the immune system. Until next time, stay curious.